Moving on from rational functions and their end behavior, we're going to talk a little bit what I like to call middle behavior for things that happen towards the middle of the graph. One of the first things we're going to talk about of characteristics of this graph that happen in the middle are the zeros of the function. Now, we talked about zeros when it came to polynomials. What were we talking about when we asked about the zeros? Fabulous. How many times does it cross the x-axis? In probably Algebra 1, you learned this acronym ROX, roots, zeros, x-intercepts, solutions. All essentially talk about the same value for a function. That is still the case here with rational functions, but we like to call them zeros because when we find them analytically, they're called zeros. Graphically, they're called x-intercepts. When it's an equation, it's called a solution, but for a function, it's called a zero. Now, rational functions have very interesting things that happen in their domain. They have both zeros, or x-intercepts, and what are going to be called undefined values. Now, we're going to really talk about what those undefined values are next class, but today we're just going to call them undefined values in the domain. So for a rational function, again, it's a fraction, so you have a polynomial on top and a polynomial on bottom. We're specifically going to be looking at polynomials today that have no factors in common, which will make more sense next time why that matters. If that's the case, then we know the following. We know that when the top of the fraction is equal to 0, then f of x is going to have a 0 at that point. So when the numerator is equal to 0, you will have your x-intercepts. You will have your zeros. But when the denominator function, when h of x is equal to 0, you're going to have what's called an undefined value. Now, again, next class we will talk about what specifically happens at those undefined values, but for today we're just going to be finding those undefined values. Why does that matter? Why in the world would something in the denominator be undefined? What's something we know about fractions and like zeros? Let me ask this in a different way because that's a confusing question. If I gave you the number 0 divided by 5, what is that? 0. If I gave you the number 5 divided by 0, what is that? Undefined. It's not 0. We're not allowed to do that. We're not allowed to divide by 0, which means that anytime your denominator is equal to 0, we're going to have this undefined value. Okay? So we have to watch out for those with rational functions because potentially they could have, preview, a vertical asymptote or a hole in the graph at those values where it's undefined. But the thing I want you to write down for all of these things, that's just some quick reminders here, is that a 0 is the same thing as an x-intercept, so you should be able to check your work today on a graph to make sure that the graph actually crosses the x-axis at the values you say it does. And number 2, you're going to have some sort of break in the domain. So the domain of a rational function does not equal all real numbers. This is one of the 3 kinds of functions we will study in this class where the domain is not automatically all real numbers. Remember, domain is the x values, the input values. This one is going to have breaks in the domain because of these undefined values when the denominator is equal to 0. So our goal of today, working with zeros, is to actually solve rational inequalities. So we're bringing back the sign chart. Here's the grumble. I hear it in your head. Okay, here's your steps for solving rational inequalities. Now we have to make sure that we're paying attention to both the zeros and the undefined values when dealing with rational functions, any sort of solving, but especially for inequalities. Number 1 and number 2 are essentially going to happen every single time. They're your setup steps. We need to make sure that the inequality is set equal to 0 and that it is a single inequality. So if I happen to give you one with multiple rational functions, we would have to combine them into one rational function. I'm not going to do that today. They will all be pretty much set up with step 1 and step 2, you being able to skip. But step 3 is really where we're going to focus. In step 3, you need to make sure that you set the numerator equal to 0 and the denominator equal to 0 to find both the zeros and the undefined values to include on our number line. So when we did this with polynomials, we just found the zeros, plopped those numbers on a number line, and had all of these intervals to test. We're going to do the exact same thing, except we have to do this with the zeros and the undefined values for each of our rational functions. We're going to be careful to mark the values where that denominator is equal to 0 so that we never include them in our solution. If we don't want to include them in our solution, when they're on the number line, should they be an open circle or a closed circle? If we don't want to include it, is it opened or closed? Open. So write that note for yourself. This is going to be an open circle on your number line. No matter what inequality I give you, the undefined values are always breaks in the domain. They're always open circles. Then we're going to test values on each interval on the number line to see if the values are positive or negative. That's what we've done before. So we're going to do a sign chart with a rational function. And then we'll interpret the sign chart to answer the given inequality, and we're going to write our answers again in interval notation. This is going to get a little complicated with the endpoints because no matter what inequality I give you, the undefined values will always have parentheses because of the open circle. So you're going to have a mix of brackets and parentheses in these kinds of questions because you could have it be equal to a 0, but definitely not equal to an undefined value. Now, none of this makes sense until we see an example. So here's our first example. Right away, it said equal to 0, so we're fine. We see that it's already factored. Amazing. We take note of the actual question here. What inequality am I asking you for? Is that where it's going to be above the x-axis or below the x-axis? Above and equal to. So think back to polynomials on that one. Well, we know that the zeros are going to come from the numerator. So if I were to solve the numerator, set it equal to 0 and solve, what would be the value of x? 2. So just like always, we take essentially the opposite number from the factor. That is our solution for any individual factor. So I know that this has a 0 at 2. I then take the denominator and set it equal to 0, and I find all of my undefined values. What are the two undefined values I get out of the denominator? -6 and 1. Now we're going to do something different. We're not just going to say that x equal to -6 and 1 because we're essentially saying that x cannot be equal to those numbers. So to help you remember that, we're going to put a slash through the equal sign, meaning not equal. Okay, fabulous. So we've got our critical numbers. We put them on a number line. I have the numbers -6, 1, and 2. Again, your number line doesn't have to be evenly spaced for me. Just put the numbers on there. Now we need to talk endpoints or circles. Around the number 2, should that be opened or closed? Closed. Why closed? Because it says 0, and what kind of question am I asking you here? Or equal to. Yeah, the zeros can be closed if this is here, the or equal to part of my inequality. But around -6 and 1, should those be opened or closed? Opened. Very good. Those are undefined values. No matter what the inequality is, they're always open because we cannot touch those. They're not in the domain. Preview. They're either a vertical asymptote or a hole, which we'll talk about next time. Okay, now we have a sign chart to create because we have 4 intervals that we need to know what's happening on the graph. Is it above the x-axis or below the x-axis? What number can I plug in for that first interval? -10. Now this gets weird because we are doing a sign chart for a fraction. If I were to plug -10 into the red part on top for the numerator, it'd be -10 minus 2. Is that a positive or a negative number? Negative. If I plugged -10 into the first parentheses in the bottom, -10 plus 6, is that a positive or a negative number? And then if I plugged it into x minus 1, negative. Oof, so our sign chart got a little weird, but remember, it's the same rules. An even amount of negatives means a positive number. An odd amount of negatives means a negative number. So if you have a negative divided by a negative times a negative, what do we get? A negative. So that section right there is negative. What number is super easy to plug in the second interval? 0. Anytime your numbers go from negative to positive, use 0. That's so easy to plug in. So we plug it in here. 0 minus 2 is a negative number. 0 plus 6 is a positive number. 0 minus 1 is a negative number. Negative divided by positive times negative is positive. Remember, an even number of negatives means that your number is positive. An odd number of negatives means your number is negative. So this section is positive. Now there's not really a cute number to plug in the next interval. What number can we use? I did 1.5 when I did these notes because that's like the nicest looking number in my opinion between 1 and 2. You can use any number that is between 1 and 2 and plug it into the sign chart. 1.5 minus 2, that's still going to be a negative number. 1.5 plus 6, that's positive. 1.5 minus 1 is still a positive number. So that section, negative times positive is negative. For that last section, really doesn't matter what number you pick as long as it's bigger than 2. What should we use? I love using 10 because it's super easy for me to use. So this is going to be a positive over a positive times a positive, which means the whole thing is positive. Okay. Oh my goodness, we did a whole sign chart. I forgot the actual question. What are we trying to answer again? So that goes back to the inequality here. That inequality is greater than or equal to. Are we looking for it's above or below the x-axis? Above. So we want all the sections where we found a positive number, which are these two sections right here. That is essentially what we did when this was a polynomial. It's the same thing, just more complicated because of the undefined values. So even though my answer seems like it should have brackets everywhere because of the or equal to, the actual way we would write an answer to this question would be from -6 to 1 with parentheses, and then change to bracket at 2 and go to infinity. Because we have undefined values at -6 and 1, we're not going to touch those numbers, so they get a parentheses. But your 2 is a 0, which means it gets a bracket. Does that make sense? Kind of, sort of? Do we need to say another example before we confidently answer that question? We want to try one on our own? How about I get you started on the next one and then you finish it? Okay, the reason I'm telling you that is because if you look at the second example here, it is not factored. So we're going to have to back up a step and we're actually going to have to factor this rational function in the top and the bottom to be able to answer the questions. But factoring should be getting pretty easy. We do it so many times in this class, it needs to become second nature. That top thing is going to factor by a shortcut. Does anyone know the shortcut? Yeah, this is the difference of two squares. So that would automatically factor to x minus 2, x plus 2. If you had to do guess and check method for it, you would be adding to 0, which means the numbers have to be opposites of each other. We get here eventually. For the denominator, what would that factor out to? X minus 5 times x minus 5, or x minus 5 squared. But we're just going to write it all the way out so that we can see all the parentheses for ourselves for our sign chart. Okay, let's answer some questions here. You started. We need the zeros. We need the undefined values. We're going to make a line. We're going to make a sign chart. There's a lot of things here. I'm going to be walking around and call me over if you need some help. In case you're stuck, I'm going to do a couple problems and then stop again. A couple parts. Just a quick question before you get too far into this problem. If you look at my number line, all of them are open circles. Why? Yeah, the actual question here was what is less than. Do any of the circles get filled in if it just says less than? No, it'd have to say or equal to for the zeros to be filled in. Okay, I'm going to let you keep thinking in case this got you somewhere. Okay, again, I'm going to continue working some sections. I see people still working, but I see some people done, so we'll just get started. But I'm going to do it silently. All right. I picked 3 on the third interval, but as long as you pick a number between 2 and 5, oh, let me go answer the phone. When we look back at the actual question, remember we were trying to figure out where the graph was less than 0, which is all of your negative intervals. There's only one negative interval once we've done our sign chart, which means that the solution to this inequality is from -2 to 2. Using parentheses this time because, again, it was not or equal to. How do we feel? Are sign charts getting a little bit easier, or are they still tough? Okay, I'm seeing nodding heads. That's good. They're getting easier. Let's go to the back. We've got a few more practice problems. Same sort of thing. We're just going to see different scenarios of stuff that could happen with the graph. All right. Example 4. It says solve 2 over x minus 3 greater than 0. We take into account the greater than 0. We just got to make sure we're answering the right question by the end. What are the zeros of this function? Well, we find the zeros by setting the numerator equal to 0. Does 2 ever equal 0? No. So does this have zeros? So we would say none, or NA, not available. There are no zeros for this graph. Interesting. Are there undefined values, though? Yeah, what number is x not allowed to be equal to? X cannot be equal to 3. Okay. If we continue working this problem the way we did them on the front, even though we've got this weird scenario, here's my number line. I have no zeros, but I have this value 3. Okay, I only have 2 intervals to test this time, the left side and the right side of 3. On the left side of 3, if we were to plug in a value, I'm going to pick the number 0 just because, again, 0 is less than 3, and that's a very easy number to use. And if I plug that in, it would be 2 over some negative number, because 0 minus 3 is a negative number. Is that going to be a negative or a positive number? Negative. 2 divided by any negative number is going to be a negative whatever. So this section is negative. What number do y'all want to plug in on the other side of 3? Which one? Great. I love plugging in 10. That's actually what I chose as well. If we plugged in 10 over here, it'd be 2 over 10 minus 3. Well, 10 minus 3 is some positive number, which means 2 divided by a positive number is still positive. What were we looking for with this question? Greater than, which is this section right here. So to write the answer here, it would be 3 comma infinity. That's the solution to this inequality. But I have a bonus question for you here. What would change about the answer if instead of greater than 0, if it said greater than or equal to 0? Would it be brackets? Brackets only show up for what? The zeros when it's or equal to. Are there any zeros here? No, so would my answer change at all? Ooh, interesting. So keep that in mind. Brackets don't necessarily mean they're in your, or equal to doesn't necessarily mean brackets are going to be in your answer anymore, because if it's an undefined value, always parentheses. Always parentheses. All right, example 5. Let's do this one again together. First things first, we check, make sure we've got a single rational function. We do, and it's got 0 on the other side. We're good to go. Where are the zeros of this function? Not 4. -2. Now remember, if it's not like easy, you may need to show a little bit of like algebra work. We get -2. Now what about the undefined values? What is x not allowed to be equal to? -5. Okay, cool. So we have 2 numbers to go on a number line. Based on the question here, which is less than or equal to 0, on my number line, I have -5, -2. Am I going to put a open circle or a filled in circle around 5? -5. Open. How about -2? Closed. Very good. All right, we're seeing the difference there. That's good. Undefined values are always open. Then we just test some values in those different intervals to see what's happening in the graph. So we would have, I'm going to, again, check -10. Just aggressively negative, so we like to use it. This would be 4 times negative 10 plus 8. Negative 40 plus 8 is negative 32. I don't care about the number, I care about the sign. Negative 10 plus 5, also a negative number, which means this section is positive. What number can we plug in between negative 5 and negative 2? Negative 3 would work. Can't use 0 yet because it didn't change from positive to negative. I know it's really tempting because it's so easy to plug in. If we plug in negative 3, 4 times negative 3 is negative 12 plus 8, that's still negative. And negative 3 plus 5, that's a positive number. So this section is going to be negative. What about that last section? What number can we plug in? 0. You could also use 10. 10 is bigger than negative 2, but 0 is easy to plug in. 0 plus 8 is a positive number. 0 plus 5 is a positive number. So that section, again, is positive. Oof, so what was the question again? Less than. So we want the negative portion. Now, again, weird, because for polynomials, you'd have double brackets on this thing. But because negative 5 is an undefined value, your solution would be parentheses negative 5, comma, negative 2 bracket. So we have to be more specific with those brackets and parentheses when it comes to rational functions. I think we're ready for a bonus challenge. So I want you to do question number 6 and 7. See if we can get the intervals for 6 and 7 where that inequality is true. I'll give you some time to work. If we zoom in on 6 here, you can write it out as showing all 3 factors on top, because I think that makes the sign chart easier, because I think the time I did the squared thing, I lost some people. So if that's helpful to write it all the way out, go ahead and do that. Either way, what are the zeros of this rational function? 1 and negative 2. I'm going to write them in number order because I can't help myself. What are the undefined values here? 2. X is not allowed to be equal to positive 2 because of the denominator. So on my number line, I would have the values negative 2, 1, and 2. Which ones get open circles? Which one get closed? Negative 2 and 1 get closed. Very good. Which means 2 is an open circle. Okay, we have 4 intervals to check. I like to throw negative 10 in there. So if we do negative 10, and I'm going to be plugging it into the one that is expanded. If you did the one with the square, we should end up with the same answer. Don't erase anything. Negative 10 minus 1 is negative. Negative 10 plus 2 is, why did I write a positive? Get that out of here. Is negative. And then negative 10 minus 2, also negative. But all of those negatives, beep, beep, bop, become positive. So that section, positive. What number can I plug in for the middle interval? 0. I guess it's not the middle. The next interval. This would be 0 minus 1. That's negative 0. Oh my gosh, saying negative and adding positives. Come on. And then positive, positive, and then negative again. All of that becomes positive. Weird. All right. F of, we're going to have to do 1.5. It's the cutest thing in the middle of 1 and 2. You could use 1.2 if you wanted, but couldn't be me. 1.5 minus 1 is a positive number. 1.5 plus 2 is a positive number. And 1.5 minus 2 is a negative number. So that section is negative. The last interval, you can use any number that's bigger than 2. I like to use 10 because it's easy. 10 minus 1 is a positive number. 10 plus 2 is positive numbers. And 10 minus 2 is positive numbers. So that section is positive. What was the actual question again? Greater than. So we want all of these positive sections. Now hopefully we all got here. Whether or not we wrote the next part correctly is yet to be seen, but if we've gotten here, we're in good point. Here's how we should write the answer. The solution set is from negative infinity to 1, close bracket, and then parentheses 2 to infinity. Why? Yeah, very good. So why did I not have to make any sort of indication that there is a 0 right here? Because it's less than or greater than or equal to. because it's greater than or equal to. If it's greater than or equal to, it's part of my unit. So I don't have to stop right here. I can just go from negative infinity all the way to 1, since that's colored in on my number line, or a closed circle. If this was open, we'd have a third section where we would have to stop at -2. But it's closed, so we can go all the way. Now the last one's kind of weird, right? Example 7. If we do this the way we've done all of them, remember the final answer here is where it's less than or equal to 0. Where is it equal to 0? Where are the, I guess I'm saying, where are the zeros? There are no zeros. 1 is never equal to 0. That's weird. There are no zeros. Where is this graph undefined? 1. X is not allowed to be equal to 1. Okay, so if I make my number line, again, there's only one number on my number line, and it's the number 1, and it has an open circle. We have 2 intervals to test, one on each side of 1. So if I do f of 0, easy number to plug in that's less than 1, we'd have 1 over some negative number squared. And I know I was avoiding the squared earlier, so you could write that out twice, but it's the same thing. Negative numbers squared become positive numbers. If I were to plug in a number bigger than 1, I'm going to pick 10 again. That's 1 over some positive number squared, which is still positive. So how do we answer this question? I was looking for where it's less than or equal to 0. Is it ever less than 0? Is it ever equal to 0? How would you answer this? No solution. Now, as we get more advanced in our classes, I know the resources you find online are going to use some advanced notation. So no solution is totally appropriate, but there is another way you might see answers written, and it looks like this. That is called the empty set. When you studied set builder notation last year for like a week in Algebra 2, or whenever you took Algebra 2, you mentioned this probably once, but it's called the empty set. You can use for me either no solution or the symbol for the empty set. I think it'd probably be easier to stick with no solution, but if you're looking up stuff online and you see that symbol, don't be freaked out. It means no solution. There is no numbers we can include in our answer where this is true. So it's empty. Cool. So we can also ask these questions from a graph. Here's where our highlighting technique comes in. On this rational function, which is kind of crazy, we are still going to be figuring out where it is above or below the x-axis depending on the question, or equal to the x-axis depending on the question. So with 3 color highlighters right now, I'm going to use green, red, and blue. We're going to highlight on the graph itself where the graph is above the x-axis, which is here, this little mini section in the middle, and then here. That's all where the graph is above the x-axis. Down here and down here, these 2 little pieces are where the graph is below the x-axis. And we have 2 exact spots where the graph touches or crosses the x-axis. I need those 3 color coding highlights on your paper. Part A of this is just simply asking where f of x is equal to 0. Meaning, what are the zeros of this function? There are 2 places where the graph crosses the x-axis. What are they? -1 and 2. So x is equal to -1 and 2 are our zeros of this function. That's where the function is equal to 0. Those are all the words that mean the same thing. For B, it says, where is f of x less than or equal to 0? The colors I used for less than is red. The colors I used for equal to is blue. So we need to answer with the intervals that are less than or equal to 0. Where does that red part start? What x value does the red part start? If I were to just kind of like beep, 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 what number is that? -3. So at -3, we begin to be less than the x-axis, or less than 0. And where does it stop? That little section. -1. And at -1, it is exactly equal to the x-axis, which we are allowed to include here because of the or equal to part of my inequality. But then there's another section on the other side. Where does it pick back up? 2 with a bracket, because 2 is a part of the x-axis. That's where it's equal to. And where does it stop being less than the x-axis? 3. Because of this right here, which again, preview, that's a vertical asymptote. We will talk about that next time. Okay, what if I asked you part C, where I'm just asking where is it greater than 0? So not including the blue parts this time, just the green. How many different green sections do you see on my screen? I should have 3 intervals in my answer. Those intervals are from -infinity to -3, from -1 to 2, and from 3 to infinity. Why are all of those parentheses? Yeah, because it's just greater than. There's no or equal to. So for sure, we're going to have just brackets. For part D, this question changes a bit. So our highlighting is not necessarily going to help us entirely with this one, because what number has it asked me for f of x to be greater than or equal to? 0. Wow, what? No, 1. Wow. What I want you to do right now is, if there is one more highlighter color you haven't used, otherwise use a pen or a pencil, I want you to highlight across the graph at 1. What is happening at the value 1 on the graph? 2 words, starts with H and then an A. Very good. Horizontal asymptote. We are asking in this question, where is the graph above its horizontal asymptote? Because at 1, you have that flat line for end behavior. How many sections of this graph are above that purple line I just drew? So we should have 2 intervals in my answer. Those intervals are from -infinity to what number? -3. Do I put a bracket or a parentheses? Very good, parentheses. And then I pick it back up at what number? 3, and I go all the way to infinity. So occasionally with these inequalities, especially with the graph, probably never with an equation because it's a lot of work to do it, we may ask you not just for where it's above or below the x-axis, positive or negative, but we might ask compared to its horizontal asymptote, what parts are above or below it. So be careful when you're looking at that. Any last minute major questions before we go to homework time? Okay, fabulous. Thank you.